Hi, we are from Group 2 and we will be presenting on food pathogen, specifically Staphylococcus aureus. My name is NURIWANI with metric number A2007551. I will begin with the overview of the pathogen and its characteristic. Staphylococcus aureus is a gram-positive bacterium with several distinct characteristics. Firstly, it has spherical shape known as cocci, and it typically forms grape-like clusters. It stands purple under a microscope due to its gram-positive nature. Staphylococcus aureus is usually found on human skin and in the environment. It is non-motile, does not form spores, and facultatively anaerobic, which means it can survive with or without the oxygen. What makes Staphylococcus aureus concerning is it can produce heat-stable toxin, which contaminate through improper handling or storage. This can lead to foodborne illnesses.
My name is NURUL JOHARI with the matrix number A2000398. Will be presenting on the types of toxins produced from the bacteria Staphylococcus aureus. How many types of toxins produced by Staphylococcus aureus? There are plenty, but I'll explain three of the main toxins, which are exotoxin, toxins secreted from the bacteria that can cause harmful effects to the host cells, including damaging tissues. Hemolysis, toxin that can cause lysing or degradation of red blood cells by disrupting or intervening with the cell membrane. Lastly, cytotoxins, a category of toxins that has a specific target to kill, for example, leukocidins, which the toxin will target the white blood cells, leukocytes, specifically and destroy it. Staphylococcus aureus has some characteristics that play a crucial role in the ability to cause diseases, such as it is heat stable and can withstand high temperature, which helps in allowing them to survive in processes that usually would kill other bacteria like cooking. Other than that, certain toxins, which is enterotoxins, an example of exotoxins, has high compatibility with major histocompatibility complex, MHC, which the interaction between the toxin and the chemical compound will trigger the activation of T cells, which will result to the increased number of cytokines, and this cytokine storm can cause gastrointestinal symptoms such as nausea, vomiting, and diarrhea. Common enterotoxins that is associated with foodborne illnesses are enterotoxin A and enterotoxin B, which will be explained further by the next presenter.
Assalamualaikum warahmatullahi wabarakatuh. My name is NURUL AINA ATIKAH binti EMZAID and my metric number is A200477, and today I will continue this presentation with the common toxin of S. aureus. The first common toxin is pore-forming toxin PFTS that will damage the cell membrane by creating pores, causing the cell to lysis and death. For example, is patent-valentine leukocidin PVL that target white blood cell and destroy them to evade the immune system. Second is superantigens SAGS. The toxin will overactivate the immune system by binding to MHC class II molecules and T cell receptor, causing the excessive release of inflammatory cytokines. For example, is enterotoxin SEA or SEB that will trigger food poisoning. The last one is exfoliative toxin ETS. This toxin target the skin, causing the outer layer to separate from the inner layer, leading to blistering. For example, ETA and ETB cause Staphylococcus scalded skin syndrome (SSS), which result in widespread skin peeling.
These enterotoxins cause rapid onset symptoms such as nausea, vomiting, and diarrhea, typically within 1 to 6 hours after consumption. The heat stability of these toxins means they can survive cooking or processing temperatures, making them particularly dangerous in contaminated foods. Contamination can occur during various stages of production, especially when hygiene practices are inadequate or when the product is exposed to improper storage conditions. High temperatures above 10 degrees Celsius and extended storage periods create favorable conditions for the growth of S. aureus and toxin production, which is enterotoxin. Mold contamination of soybean before fermentation can also lead to the presence of harmful compounds. Preventing enterotoxin-related food poisoning in tempeh requires strict adherence to hygiene practices throughout the production process. This includes maintaining clean equipment, avoiding cross-contamination, and ensuring proper storage at or below 4 degrees Celsius to inhibit bacterial growth and toxin production. Additionally, microbial testing of raw soybeans and finished tempeh products is essential to ensure food safety. By following these measures, the risk of foodborne illnesses caused by enterotoxins in contaminated tempeh can be significantly reduced.
I'm YING and my metric number is A20093. Today, I want to share about the factor that affecting the toxic production. Firstly, I would like to talk about the water activity. The optimum goal range is about 0.83 to 0.86. Higher water activity provides an ideal condition for the growth of S. aureus. However, the toxic production is more sensitive to water activity than the bacterial growth. Even if the bacterial growth at lower water activity, toxic production may increase. S. aureus is relatively tolerant to dry conditions. This is because at lower water activity, S. aureus experience osmotic stress, which inhibit the metabolic activity, including the toxic synthesis. Besides, the nutrient content also affects the toxic production. S. aureus thrives in protein-rich, nutrient-dense foods such as meat, egg, and dairy products. High protein content support the rapid bacterial multiplication and enterotoxic production, which cause the food poisoning. The production of this toxic depends on the availability of the nutrients. Toxic production typically occurs during the exponential phase of bacterial growth, when the nutrients are abundant and the energy is directed towards the biosynthesis. Hence, the proper storage and regurgitation of nutrient-dense foods are essential to prevent the growth of S. aureus.
Hello, my name is VYVIEN RANDAI with metric number 8200599. Next intrinsic factor will be pH level. Common pH level for most pathogen to grow is between 4 to 10. However, for S. aureus, the optimal growth pH level is between 6 to 7, which tend to be in more neutral condition. Inconsistent pH level will cause enterotoxins production instability, food safety implication, and some S. aureus strains will still survive in certain preservatives. Hello, I'm VYVIEN RANDAI with the metric number of 8200599. Next, I will talk about one of S. aureus' extrinsic factors, which is temperature. The common temperature range for most pathogen growth is between 6.7 degrees Celsius to 47 degrees Celsius. The optimal growth for S. aureus is between 35 to 37 degrees Celsius. Temperature fluctuation will impact in slow production of enterotoxins, food safety implications, and will cause thermal resistance in some of S. aureus strains.
Hello, my name is NURIWANI Aqilah binti Muhammad SAYUTI with the matrix number of 8200445. I'm gonna explain about the second extrinsic factor, which is humidity. Let's look at the high humidity. So high humidity promotes the growth and toxin production by maintaining optimal water activity. So food with high moisture content such as dairy or meat product are especially prone to the contamination and toxin production. So let's look at the low humidity. Low humidity inhibits S. aureus growth and reduces toxin production. Drying food or using desiccant can lower water activity, so it prevents the toxin synthesis. The third factor is storage condition. Let's look at the oxygen level. S. aureus is a facultative anaerobic and can produce toxin in both aerobic and anaerobic condition, though aerobic condition may enhance the growth. The second one is packaging. Sealed and low oxygen packaging can slow bacterial growth, but toxin may form if the contamination occurs before the packaging. The third one is cross-contamination and poor hygiene. So improper storage or handling, such as at room temperature, can exacerbate toxin production. And the last one, time. Extended storage at suboptimal temperatures significantly increases the risk of toxin accumulation.
Hi, I'm BATRISYIA with REMLE, ID number 8200634. Today, I will be explaining the pathway through which Staphylococcus aureus can contaminate tempeh during its production. Starting with the raw material stage, contamination can occur when raw soybean are exposed to unsanitary conditions during harvest, storage, or transport. Additionally, food workers with poor hygiene such as unwashed hands or open wounds can introduce S. aureus during washing, soaking, or dehulling. If the soybean skip the boiling step before fermentation, the risk of contamination increases significantly. Moving on to the fermentation process, the temperature and moisture required for fermentation, typically 30 to 37 degrees Celsius, create an ideal environment for S. aureus to grow. This is particularly true if fermentation lasts too long, exceeding 48 hours, or if the fermentation containers or starter culture are contaminated. After fermentation, in the post-fermentation stage, contamination can occur during slicing, packaging, or handling using unsanitized tools, touching tempeh with unwashed hand, or cross-contamination with other foods can introduce S. aureus. Additionally, tempeh that is not pasteurized allows bacteria to multiply, leading to potential spoilage and microbial growth. Lastly, during storage, improper condition can further promote contamination. Keeping tempeh at room temperature for extended periods allow bacteria to thrive within the danger zone of 4 to 60 degrees Celsius. This not only accelerates microbial growth, but can also cause ammonia buildup and the growth of black spot from mold over time.
My name is Nuru'aini binti YAZID. My metric number is A20771, and I will explain the mechanism of infection by Staphylococcus aureus and food contamination in tempeh. As we know that as we consume the food contamination that causes the S. aureus, it will lead to the infection of digestive system. First, SRS produce the extra-toxins, which is super antigens, that contaminate the TMP, which this toxin will enter the bloodstream and interact with the antigen-presenting cell, causing the immune dysregulation. And the toxin will trigger the intestinal inflammatory response, which leading the mast cell degranulation and irritates the digestive tracts. And second, it will lead to the infections and inflammatory. As immune infection, the bacteria use this mechanism like antiphagocytic capsule, protein A for masking, and biofilm formation to survive and invade the immune system. As the host cell, S. aureus binds to the host tissue using fibrinogen binding protein, teichoic acid, and clumping factors to enhance its ability to colonize and cause the disease. So as the outcome, the contamination food from the S. aureus, it will cause a disease such as diarrhea, gastroenteritis, urinary tract infections, and more diseases.
Assalamualaikum and hi, my name is NURSABRINA binti YAZID A200891. We present about the overview of the foodborne disease caused by Staphylococcus aureus toxins. Firstly, I will talk about the characteristics of the toxins. Staphylococcus aureus toxins are extracellular proteins released into the environment such as food. They are highly stable, resistant to heat, cold, and low pH, making them difficult to destroy even with cooking or freezing. These toxins are also resistant to the digestive enzymes like pepsin and trypsin, allowing them to remain active in the digestive system. They can cause emetic effects leading to vomiting and act as super antigens, triggering massive T-cell activation and severe inflammation. Additionally, as little as 0.1 microgram of the toxin can cause food poisoning. Next, it is the source of the contamination. Staphylococcus aureus is commonly transmitted through human carriers, improper food handling practices, and respiratory secretions during coughing or sneezing. Contamination can also come from animal origins, affecting foods like red meat, cooked meat, chicken, canned meat, tuna, and dairy products such as cheese, raw milk, shelled milk, and cold milk. The bacteria have also been isolated from food preparation containers, making them one of the most common vehicles for S. aureus transmission. Proper hygiene and careful handling during food preparation are essential to prevent contamination. Furthermore, I will talk about the symptoms of food poisoning. Symptoms of Staphylococcus aureus food poisoning typically begin abruptly, with severe nausea and vomiting occurring 30 minutes and 8 hours after consuming contaminated food. Other symptoms include abdominal cramping, diarrhea, headache, and fever. These symptoms usually last about 1 day and recovery is generally complete.
Hi, I'm AFINI. My matrix number is A200439. Everyone can be affected with foodborne disease. However, there are some group of people who are most likely to develop more severity symptoms towards the infection, and they are adults at the age of 65 or older, children less than 5 years old, people whose immune systems are already weak, and pregnant women. Next, I will be explaining about how do we prevent foodborne diseases. There are 3 main parts in which we can practice in order to prevent foodborne disease. First is personal hygiene. Washing hands often and avoid cooking when sick, as the body immune system are already weak. Next is proper food handling, such as using clean utensils and surfaces, separate raw food and cooked food, and to thaw food safely by not leaving it at the room temperature for a long time. Lastly is practice proper cooking by cooking food to a safe temperature and reheat leftovers sufficiently. As for the storage temperature control, perishable foods need to be refrigerated and the food needs to be labeled with expiration date. There are many cases on foodborne disease. One of the cases were food poisoning caused by Staphylococcus aureus outbreak in primary religious school student in Bangi. On the 2nd May of 2017, several students who ate at the canteen present with symptoms such as abdominal cramp, diarrhea, vomiting, and nausea. These symptoms were a mix of gastrointestinal tract and lower as reported in the S. aureus food poisoning symptoms. The cause of this outbreak was the beef curry, and the contributing facts was unhygienic practice of the food handlers at the canteen. Thus, in conclusion, basic principles of safe food handling should be emphasized as food poisoning poses threat that may cause life.
In conclusion, Staphylococcus aureus is a bacterium that can contaminate food. It is because they produce heat-stable toxins which cause food poisoning. Proper hygiene and sanitation practices are crucial throughout the production process, which is from the raw materials to finished products, to minimize the contamination risk. Understanding the factors affecting bacterial growth and toxin production is essential for ensuring the safety and quality of this fermented food.